our next speaker has judged more talent shows than he has participated in. No. He's judged more talent shows than he's even attended. I'm not sure how that happened. He must be a prolific talent show judge. Everyone, please welcome Emil.
Before we get started, can we have a show of hands of people that know about Advent of Toad? So for the few of you, the next couple of slides won't be that interesting, but I have to explain what it is before we move on. So Advent of Toad is a yearly competition that started in 2015 with daily challenges from December 1st through December 25th. Each day is comprised of 2 questions, and it's a programming challenge, but you're really allowed to do whatever you want, and people do whatever they want. So, and over the years, there's a lot more. We now have over hundreds of thousands of users every year. So when you log in and it's your day, you open up a page, and this is what you see. You see a bunch of text describing what's going to happen for you that day. But it's being broken up in a very specific way. So part of the text will be some kind of story that is completely unrelated to the problem you're trying to solve. So last year, the overarching theme was that you were on a submarine ride. So there's going to be some submarine-related stuff up here, something about magical fish. Has nothing to do with what you need to do. Next, there will be the actual problem statement of here's your input, which either will be a couple of numbers or a very simple text file you can download and use as your input. And it will explain what to do and what it wants back from you. And then the majority of the problems will also have a word-through example, so sort of like a unit test. It will say, oh, if you have these numbers, but these ones don't. So when you're trying to figure out how to solve this problem, you can work through these before submitting your final solution. Once you did it right, you will be presented with a part 2. And the part 2, a lot of times, is related to part 1. So sometimes they're very related, and sometimes they will be completely unrelated. But you don't know that until you actually solve the first part. So you're not able to optimize your part 1 solution unless you cheat and do it a day later and look up what other people said it was about. So I want to go back to the moment I realized that I needed to stand here and do this talk. Way back when, in 2020, December 1st. So I was sitting already, like many others, all alone at home, waiting for the timer slowly to go down. If I remember correctly, the new day opens up midnight at East Central Time, which is a horrible time for a lot of the world. But me on the West Coast, 9 p.m., it's not that bad. It doesn't interfere with anything I have going on. So I can be ready every time. And the question was quite simple, as they are. The question starts simple and then slowly gets harder under some hard metric of how do you define what a harder question is when they're all unrelated. But I was given a list, or we're all given a list of many different integers, and I needed to find the 2 entries that summed to 2020. Very appropriate. And here with the solution. You should never use code like this, but I have a classic 4.4 if return statement. But of course, you don't need curly brackets. And it was this wonderful solution. I submitted in, I clicked to find out what part 2 was, and the website didn't work. And I wasn't the only one, because the AWS instance completely died. Because having a website with hundreds of daily viewers that suddenly have 50,000 viewers within 2 minutes doesn't really work, so they had to completely kill the instance to open a new and better one up. And this is the moment I realized why these problems are interesting. Because what I need to do, I knew. And I knew that the next part is going to be a little bit harder, but related, but I have no idea what to do. So you end up with so many different opportunities to solve your problems that there's not one clear answer. Well, there's one answer, but there's many routes to get to that answer. So I used my lovely for loops. Later, I became an avid user of repeat break statements, which, if you're not careful, will just completely loop forever. You could also use a different product, do expand grid. So I needed to find two numbers that sum to something, give me all the combinations, and it will work fine. Of course, if they asked me for the 10 numbers that sum to something, this will probably break, because then suddenly we have a lot of different combinations. We might have memory issues. Another kind of solution to just be sample to random numbers, because it isn't necessarily about finding the best way of getting the solution. We just need to find the solution. So random sampling two numbers over and over then would eventually get us to the right thing. So while I was agonizing, waiting, refreshing over and over then to get in on the leaderboard, someone decided that, hey, RStudio, that's the way to do it. So for those uninitiated, RStudio is an esoteric language that reads like lyrics. So this piece of code will give you the same solution as what I showed earlier. And this is why it's a wonderful competition, because people use the lame solutions like C++, Python, R, JavaScript, and then they use the weird stuff. That every year, someone will see how far can I go only using Vim commands, or how long can I go in a spreadsheet, which these are not created for that, but you can do it sometimes. And there's many different types of solution, which is where I thought I learned something new, because some of the problems will require recursion. There's a lot of grid-related ones. We have a two-dimensional grid of values. It would be here the trees, how to find a solution. Sometimes it's maze-related. But one of my favorite types of problem that are really benefits from is these Parsable Solutions. So let me show you a quick example. So here's my input. We're writing a submarine, and we need to go forward, down, and up with a certain amount. And boring answer would be to do a for loop and some if-else statements to update some things. But that's not fun. What we do instead is turn this into parsable R code, define a forward, down, and up function, and simply just parse. Then suddenly the input turned into valid R code that when run will give you the right solution. It's not necessarily a pretty solution, but it works. And it's fun, and that's why I do it. Another type of problem which comes up a lot, and last year I fell in both feet first, is the idea that some of these problems are created to trick you. So last year we had the Lanternfish problem, where you have a number of lanternfish that are denoted by how many days until they reproduce. So every day, all the numbers go down. Once you hit 0, your own number goes up to 6, and you add another lanternfish with the number 8, and that continues. So just over and over then. It's a fairly simple system. It grows very fast. So the first part of the question was, how many fish will you have after 80 days? And the next part was, how many will you have after 256 days? And even the most naive solution for the first part will run basically instantly, and will be fairly small. The final vector representing the lanternfish will be around 1.5 megabytes. But if you use the same solution and just change 80 to 256, you end up having the final vector be over 6.5 terabytes. And if you do it really naively, you end up allocating 400 terabytes worth of vectors to get to the end. So of course, this isn't the right solution. And I should have known that, having done these for a couple of years, that if you see anything with a number, he's going to do a better number later that's going to completely break everything you're doing. But I found that my general workflow going through this resembles a lot of just data analysis stuff. So you always start reading in the data, and working through these problems made me realize how grateful I am that other people are writing code to read in data for me. I never have to parse JSON. I never have to work with CSVs or anything else. People are working hard to make sure I never have to do that. And we never have to do that as a group. It's done somewhere else. Once you read it in and have it in the right format, you need that in the right format because, and I made a controversial statement by saying that all problems can be solved either using matrices or data frames or lists. But most of the time, there's one obvious solution. So like anytime you use a data frame, you could use a matrix. You just don't have the worst time if you have mixed like types. So the big part of the problem is finding the right representation for whatever problem you're working on. And then, of course, unit test, working through the small parts. Because I've really been humbled over these competitions by being very confident that I knew how to code something correctly the first time, and getting an error back saying, hey, this is like completely wrong, and realizing, oh, too many minuses, or something like that. And the last part and smallest part is the solution. But this is by far the smallest part. And yeah, so that you end up doing a lot of work in calculations simply because we don't have to read in data anymore, or write the code to read in data. So the first takeaway is, if you join me in this journey later this year, you might learn something. Like I learned many different things. I became much more familiar with lists, other control structures other than for loops, because some of these problems can be solved with for loops. You might have recursion or other repetition to find the first number that satisfies the condition, and that's really hard to do in a for loop. You have to try other things. And we have many ways to play this game. So personally, I like to go for speed. I go as fast as I can. I break all the style guides available. One time, instead of modifying a for loop, I instead copy-pasted the code 4 times and modified it a couple of times because it was faster in human time, not code time, not anything else. But I wanted to go as fast as possible. Other people go for elegant solutions. You can do a no dependency or a specific kind of dependency. You can say, hey, I want to try to get better at tidyverse, or I don't want to use tidyverse, or like you can even say, I want to do another language. A lot of people take this opportunity to dabble in other things because you have some problems that you can solve that is solvable in most programming languages. As I said, my main mode is can I go as fast as humanly possible, which, of course, I won't ever be the best because we have someone like David Robinson who outspeeds everybody. So last year, David Robinson was the 3rd worldwide to get both stars. And it's insane because what he did was click on it, open the window, read the prompt, download the data, switch over to RStudio, write the code, get the answer, back in the browser, plug it in, read the next prompt, write new code, get that answer, put it in less than 80 seconds. Where many other mortal people almost finish reading it after 2. So it's just, I can't beat it. But you still you can go at your own pace. Like, there are certain ways you can optimize, but we're here to have fun, and we can do it in all our own way. We have like the leaderboard that generally just takes how long did it take for you to finish this problem from the time it was released. This heavily biases toward people like me that don't have any responsibilities at midnight East Standard Time. So it's wonderful for West Coast people, horrible for Europeans. We had a community leaderboard that instead balanced it out a little bit by ranking us by how long it took us to get the second answer after we got the first one. So regardless of when we started, you can still rise up as long as you don't cheat and look at what both of them are. And the art community is awesome. I can't show too many of it, but we sent like so many memes, Slack channels, private messages, just having a good time. People tend to post the solutions. I have the prettified versions of my solutions up on a website I made, and you learn something. I learn something every time David Robinson puts out his dplyr code, trying to write solutions that are not meant to be written and solved using dplyr code. That's like second takeaway. We learn so much by doing things together in public. And lastly, there's so many different types of problems being represented here. So to name a few, we have the squares with 3 sides, which essentially give you a list of 3 numbers, and you need to find out, is this a square or a triangle? By those numbers. We have the encoding error, which find the first number who is not a sum of a subset of the 15 previous numbers. Or we have Wizard Simulator, which in essence is programming a turn-based RPG from scratch to find out the most optimal purchase of spells and weapons. But the overarching theme is that all of these problems are so very clearly written. I always knew exactly what I needed to do. Or to be more precise, I knew what answer they wanted from me. Sometimes I had no idea how to get there. And I think if you're involved in any teaching or creation of educational material, I would highly encourage you, even if you don't want to do any of the problems, read through them and figure out some of his tricks. And maybe even one day we can get a data analysis clone to this much more computer science heavy competition. So, my take home is you might learn something. I definitely learned something. It depends. You don't have to do all of it. Like many people will say, I'm going to spend 30 minutes each day because then it's the busiest time of the year. Like it can be hard to squeeze in multiple hours every day. Last year I stopped on the 15th because it just became too much. And you can always do them later in the year. If you haven't already, you should join the art community. Like just be with each other, which we're doing right now. And it's like completely awesome. And then lastly, and most importantly, you might have a little bit of fun if you're into puzzling and doing weird things with art. Thank you.
Thank you very much.